Okay, so I forgot to hit record, so here's recording the YouTube stream. We haven't done anything important yet, so this is where the YouTube stream will start. Yeah, technically 18 is still about Eminem Boy. Problem 14 all the way through 18 is about our misadventures of this fourth grade student. Poor kid. Let's look at that right now. So, Olivia, if we go to Canvas, right? So here's Canvas, right? Always. So always go to modules. That's going to be the best place to look. So modules. Oh shoot, does Weaver? I wonder if Weaver hasn't posted it yet. Weaver. Um. So oh my gosh. Okay. Let me give you guys a link to it. Oh, okay. So you haven't done the submission, but you have the actual assignment. Oh, so Weaver says he has the assignment there. So he should have it. He should have this factor label assignment somewhere. So if we look at the chapter 2, Mr. Weaver, where is it on your canvas? There's a link on the homepage, he says. So on the homepage, if you're in Weaver's class, there should be a link somewhere. Chapter 2. Oh, now Drake finds it. Okay, so for my class in modules, my class is, it's also in the module section. There you go. So in modules, right, we want to close out all these. We've done all this chapter 10. We've done the chapter 13, 50 stuff. We don't want, I just kind of, you can click the little arrow and it'll minimize them if you didn't know that. And so then here's our chapter 2. This is the stream from Monday that kind of introduces the topic. So if you missed Monday's stream, go back, make sure you watch that. Here's the assignment. I've already, if you click this, it'll bring up the document in the PDF, right? I've already downloaded that, and so the assignment's here. It should look like this. Access was denied. That's weird. And then the submission assignment it's just the questions repeated, and then you just enter the answer. There must be something weird. You might have to like re-upload the file or make it public or do something. So Weaver will figure that out. I'll kind of here. I'll leave the assignment open. Let me put it in the. If you guys are in the Discord, I'll just put it in the Discord real fast. So honors questions. Let's look at factor label assignment. Upload. Here, so I uploaded in the Discord, so you can download it from the Discord if you want. That works too, if you have access to the Discord. Yeah, there might be something weird about the permissions. No, it's fine. It's fine. It's hard to coordinate. Weaver and I haven't coordinated as much as we should. We should have done a little more yesterday. We've been dealing with the schools getting demolished and having to move everything out of our classrooms and all this other stuff. So now that's weird, Icy Snow. I don't know what to do for you. Yeah, Canvas is a little bit junky. Icy, you can try that link if you want. Okay. Apparently Trinity sent Tyler a Snapchat of the assignment, so you can have that. All right. Let's go ahead and do. I have it. Yeah. No, we packed up everything. The Tesco is in a random box somewhere. I don't know where it is. I would not want to use that anywhere near my computer, though. That sounds like a electrical hazard waiting to happen. All right, so number 7, I'm going to jot down some pieces of information so that we can kind of work through number 7. So, so I did save the love thermometer, don't you worry. So, how many grams does a sheet of paper weigh? You guys are all worried about the love thermometer. So what I wanted to emphasize real quick is the setup of this problem. This problem is really simple. It says how many grams does a sheet of paper weigh? And so when we start the problem, we want to start it as, okay, here's number 7. The question is how many, so I'm going to put a blank, how many, right? How many grams, right? So how many grams, right? The problem is, or the question is, how many grams does a sheet of paper weigh? So how many grams, blank grams, is equal to 1 sheet, right? So what I find that a lot of students struggle with is the setting up of this problem, okay? Is getting this set up right will lead you to getting all the problems right? So you have to kind of walk through this way. So how many grams is 1 sheet? So then we go to the problem and we say, okay, well, what do we know about sheet? Because our next goal is going to be to cancel out sheets of paper. So we need to have something about sheets on the bottom, and we're going to convert it to hopefully get us closer to grams. So if we look at this, okay, oh my gosh, now we're quoting The Office. All right, so if we look, we know we've got this first thing. So we have 25 sheets is a quire, right? It's not a queer, it's a quire. Fancy. So apparently 25 sheets of paper is known as a quire, if you didn't know that. Yeah, let all right. So anyways, 1 quire is 25 sheets. Then we know, so is that the only thing we know about sheets? That's the only thing we know about sheets. So that's going to be our next conversion as we write it down. So we say 25 sheets is 1 quire. Okay, so notice sheets go on bottom, so they cancel, right? And then we have 25 sheets as a quire. Now we're trying to get to grams, so that means we have to turn quires into something else, right? So what do we turn quires into? Well, go back to the problem, right? We know 20 quires is a ream, and that's all we know about quires. And so since that's all we know about quires, we can use that next, right? So 20 quires is 1 ream. Okay, so again, we're canceling out these units. Sheets cancel with sheets, quires cancel with quires. Now we have reams, right? And we got to get reams down to grams. So I'm going to do a page break here because I'm out of room. So we got to say something about reams. Now this is where you can get a little bit lost in the problem, is because of this idea. The problem is we've got we've got 1 ream is 3.02 pounds, and we also have 8 reams is a case. So we know 2 things about reams. We know reams are equal to pounds and reams are equal to cases. Now, if we look at this case, we don't know anything else about cases. And so case is actually a dead end. And so sometimes you'll have conversions that you could do, but they don't get you to the answer. And so we get left with the dead end. So we're not going to use this 8 reams as 1 case. This is a red herring. It's a deceptor, right? So we're not going to use that one. So we are going to use this 1 ream is 3.02 pounds. Eliza, I'll answer your question here in a second. I did see it. So 1 ream, 3.02 pounds. 1 ream, 3.02 pounds. So Eliza asked a really good question. She says, why are we canceling out sheets if that's what we're figuring out? The thing is, we're not figuring out how many sheets are in a sheet, right? Because 10 sheets of paper is 10 sheets of paper, right? That's obvious. What we want to know is we want to know how many grams are in 1 sheet. So what we're doing here is we're changing this 1 sheet into some amount of grams, and that's kind of the process. And so in order to change sheet into grams, we have to get rid of the sheet unit, and so we have to cancel sheets. So sheets cancels, quires cancel, now reams cancel, Okay. If we were to stop the problem here, we would find out how many pounds one sheet of paper weighs. That's not really going to be useful. It'll be a small decimal. Okay, so we got to keep going from pounds. So we know a lot of things about pounds. We know there's 16 ounces in a pound. We know that 2,000 pounds is a ton. We know all these things. But the problem actually gives us a little more guidance. So the problem tells us that 2.2 pounds is a kilogram. Metric system, kilograms. Okay, so 2.2 pounds is a kilogram. And then since we're here, 1,000 grams is a kilogram. So we have these next two conversions. 2.2 pounds is a kilogram, 1,000 grams is a kilogram. So we go back to the problem. And we say 2.2 pounds is 1 kilogram, and 1 kilogram is 1,000 grams. Okay, so Sadie now knows what she messed up. She had everything flipped. Okay, so and that's why I'm betting that you probably got off right at the start. Okay, having this set up right at the start and canceling everything you go should keep everything in the right order. And notice, right, we're left with grams. So all these other units have canceled. We're left with grams, and now it's just up to putting in the calculator. So Zach asked a question, how do you determine what's on top? And the way you determine what's on top is just following the units, right? We had sheets here, so we know sheets have to be on bottom. We had quires here, so we know quires have to be on bottom. We had reams here, so we know reams have to be on bottom, right? It's so everything cancels. So Zach and Olivia asked the same question there. I hope I answered that. Yeah, it's math, not meth, Drake, math. So at this point, plugging in your calculator, you have a couple options. You can multiply everything on the top and get a number, multiply everything on the bottom and get a number, and then divide those two. Or you can just multiply across. You can take 1 divided by 25 divided by 20 times 3.02 divided by 2.2 times 1,000. And when I do that, I get 2.75-ish grams. 2.75, 2.8, somewhere in there. So a single piece of paper, according to this math, weighs about 3 grams. So there you go. Grams are pretty light. People don't realize how light a single gram is. But a piece of paper, more like copy paper or printer paper, a little more thick, would weigh about 3 grams. Gosh, Drake, don't insinuate that you sell meth. Making methamphetamines is not incredibly difficult. I've never done it, and nor would I ever do it because it's illegal. But if a random crackhead off the street can make it, pretty sure anybody can. So Xander, that makes me think you might have plugged in 100 and not 1,000 here. You're missing 10 somewhere, so you're off by a factor of 10. My bet is this last one. Good old Breaking Bad. Ugh, that shows it's so good, but it's also terrible at the same time. Really? I mean, to make it to a high purity, I would understand. So Weaver, it would be difficult to make it like really high purity, but I bet you could get like a 80% purity pretty easily. Just take pseudoephedrine and add some other stuff. It's not really worth it anymore because the Mexican drug cartels pump out meth really easily now. It used to just be cheaper to buy, or it's cheaper to make it like in random labs in the US, but the drug cartels have made it pretty cheap and smuggle it across the border. Drugs are fascinating. Don't do them. Don't do drugs. Seriously, if you want to throw your life away. No, we would not make illegal drugs as a lab hunter. That would be a very bad thing. Steroids is an interesting topic, Tyler. Yeah, that's the thing. I would imagine the yields are really poor, but you could still get something. Yeah, don't leave off that don't, Cooper. That's a pretty important part. That's so interesting that they had really low yields. In number 12, you don't have to use your answer from number 11, Olivia. You just have to use the same conversions. Okay. Oh, are we asking about number 12? Do I want to do number 12? So Weaver says his canvas is fixed. So those of you in Weaver's class, you can get access to the document now. You should be able to. Okay. Oh, sure. So if we want to combine the tops, right, it would just be 3.02 times 1,000, or 3,020, divided by 25 times 20 times 2.2, divided by 1,100, which gives us our 2.75. All right, well, I'll do 12. We'll do 12. So on 12, okay, so we have confirmation from Tyler that the canvas works on Weavers. All right, so 12 is kind of randomly shoved in here. 12 asks, how many hides are in 23 nooks? Yeah, Chris, so that's why number 12 is kind of randomly in there. Yeah, okay. So Chris has figured out, he spotted it. Same thing with 16. I didn't bold 16. I should have bolded 16. Yeah, same thing there, Tyler. Same thing on 16's in the middle. The problem is they like build. So, okay, so Drake's asking, what is a nook? So during earlier times in England, land was measured in units such as fardels, nooks, yards, and hides. 2 fardel, or fardel, I think it's fardel. 2 fardels is 1 nook, 4 nooks is a yard, and 4 yards is a hide. A legend is sung back in ye old England days. No, these are real Old English units of measure. I can't remember exactly what they are, but so the question on 12 is how many hides are in 23 nooks? Yeah, the jiggles and pobeds is totally made up on number 10. All right, so let's look. So the question is how many hides are in 23 nooks? So we want to say how many, so blank hides are in 23 nooks. I'll take a break here to remind you that when you submit your work for the problem, it has to look like this. If it doesn't look like this, you're only going to get 50% on the assignment. Even if you have every single problem right, your work has to look like this. You have to show the units being canceled. You have to have the setup kind of along these lines. So make sure that you have the setup looking like this. Some of you have much smaller handwriting. I'm writing kind of big to show everything on the camera. But if you have smaller handwriting, that's fine. But it needs to look like this. Okay. So how many hides are in 23 nooks? So the first thing we want to do is we want to change nooks, right? So if we go back to our problem, okay, let's see what we've got in the problem. We've got 2 fardels is a nook, 4 nooks is a yard, 4 yards is a hide. So how many hides are in 23 nooks? So the only thing we know about hides is yards. So we're going to do this first 1 hide is 4 yards conversion. So, oh wait, no, that's not going to help us. We have nooks first. So we got to start with nooks, right? I got thrown off. So let's go back to it. We have nooks. So we need something about nooks. Oh, the only thing we know, we got, oh wait, oh, we know 2 things about nooks. So we know that a nook is 2 fardels and 4 nooks is a yard. But in terms of getting us closer to hides, we're going to have to go into yards because we know yards is hides, right? And we know nooks and yards. And so instead of changing nooks into fardels, which is a dead end, we have to change nooks into yards, okay? So that's kind of the idea. So we're going to do 4 nooks is 1 yard. So 4 nooks is 1 yard, right? So nooks will cancel to give us a yard. And then we say 4 yards. Hey, the Shaw chemist. Thanks for the raid, man. We're just going over some factor label dimensional analysis. Appreciate it. So 4 yards is equal to 1 hide, is what we said here. 4 yards is equal to 1 hide. And so then at this point, right, our units cancel. Nooks cancel with nooks. Yards cancel with yards. We get left with hides. And then, so then our hides, right, which is what we wanted to find. So we take 23 divided by 4, or just 23 divided by 16. And we get 1.44. So what's a raid, Drake? Those of you that aren't new to Twitch. Yeah, that's totally fine, the Shaw Chemist. You can definitely use your primes going to them. Totally not Mark. I'm guessing your name's probably Mark. So yeah. So a raid is when, so if at the end of the stream, if I wanted to send everyone who's currently watching to someone else's stream, we could then go raid that person's stream is the idea. And so what it does is it takes all of my current viewers and we all go to someone else's stream. And so that's why, 32 people just popped in here randomly. So yeah, hopefully you guys can enjoy some simple factor label. Dude, yeah, HyperX Cloud 2s. They're great. Okay, so if we go back to this, so our question was how many hides are in 23 nooks? So randomly kind of weird old English measurements. How do you know to stop when converting? That's a great question, Tiara. So let's talk about it. So if we look at this, our original question was how many hides are in 23 nooks? First thing we did is we changed nooks into yards, right? Nooks cancels. Then we changed yards into hides. So Tiara's question is, well, why don't we just keep going? The reason why we don't keep going is, remember, what are we trying to find? We're trying to find hides. And so since we have hides and we were trying to find hides, then we're done, right? So that's how we know that we're done with the problem, is when our last unit here matches up with what we were solving for initially, right? So now our hides equal hides. It depends what the Shaw's Chemist, I don't know about the Shaw's Chemist page. We'll have to shout him out. We'll have to check it out. Rousseau's class. All right, next thing we're going to do, we were going to do 14. All right, here we go. So let's go down to 14. So this is the beginning of our unfortunate tale. So 14 says, an enterprising decides to make profit by selling M&Ms to first graders. The student first bought 1 package of M&Ms at a candy machine for 55 cents and sold all the M&Ms one at a time for 2 cents each. The contents of the 1.69 ounce bag sold for 114 pennies. How many M&Ms were in the package? So this problem has a lot of information in it that you don't need. Yeah, the 4th grader should definitely sell meth. Again, he's an enterprising 4th grader. This kid's an entrepreneur. He's got business ideas. He's a big thinker, right? So the question, if we go back, right, the question is how many M&Ms are in the package, right? How many M&Ms are in the package? So he doesn't make the map, he finds the map. All right. Okay, so the question is how many M&Ms, so blank M&Ms, right, we're in 1 package, right? So we got to go back to the problem. We got to see, okay, what do we know about the package? what do we know about this package of M&Ms? So we know a few things. We know that he bought it for 55 cents. We know that it was a 1.69 ounce package. And we know that it sold for 114 pennies, right? So we know all three of those things about this M&M package. But only one of them is going to get us to the number of M&Ms, right? So what do we know about the number of M&Ms? The only thing we know about the number of M&Ms is that he's going to sell the M&Ms one at a time for 2 cents. And so we know he sells them for 2 cents. So what we want to do is we want to look at how much the bag sold for. That's going to actually get us where we're going. We don't care how much he bought it for. We want to do how much he sold it for. Okay? And so that's kind of a key thing of watching these units. So we know that the package sells for, so one package sells for 114 pennies. Or we'll just say 114 cents. Okay? And then we know that he was charging 2 cents for every one M&M. I'm from Australia. Why are you watching this? I have no idea, my dude. And so, so the math is really simple. It's just 114 divided by 2. And so the answer is 57, right? Tyler's struggling on the math here. It's 57. Okay. If it was 144, then it would be 72. There we go. Okay, yeah, I was like, he had to get that from somewhere else. Yeah, it's 114. So apparently this package of M&Ms has 57 M&Ms in it. So this leads into the next problem, problem 15. Problem 15 is a little trickier. Okay, so on problem 15, right? We ask about, he says, okay, the first venture went so well that the student bought a 3/4 pound bag for $2.40. How many M&Ms are in the larger package? Okay, so we know two things about this larger package. We know that it weighs 3/4 pound, and we know that he bought it for $2.40. Okay, so if we go back, right, we want to know how many M&Ms are in the large package. So one, we'll call it LG package, right? So how many M&Ms are in the large package? Now, sometimes when students do this, we get a little confused because we know that 2 cents is an M&M. And so sometimes you're like, oh, well, let's just use 2.40, and then we say 2 cents is an M&M. The problem is this isn't how much he sold it for. This is how much he bought it for. Okay. Okay. So we have this 3/4 pound bag. How much it weighs, that'll actually help us get to the number of M&Ms. And this is where it gets a little tricky because we have to talk about, well, we know that back here, we know the small bag weighed 1.69 ounces. Right? So if we know how much the small bag weighs and we know how much the big bag weighs, we might be able to relate the two together. Okay. So let's kind of get into these conversions. Let's see what we get. So we know that the large package, one large pack, weighs 3/4 pound or 0.75 pounds. Now, every good American should know how many ounces are in a pound. How many ounces are in a pound? Of course, we're talking avoirdupois ounces, not Troy ounces. That's a different story. So, and then we said that the small package was 1.69 ounces for the small package. Okay, so one large pack is 0.75 pounds, 1 pound is 16 ounces, 1.69 ounces is the small package. And the last step, we actually can use our answer here because we know that the small package had 57 M&Ms in it. And so we just kind of tack on one last step. where we say one small package had 57 M&Ms. And so then we just do the math. So we say 0.75 times 16 divided by 1.69 times 57, and we get 404.7, or approximately 405. Right? Here, we'll give some big brains for Tyler. All right, so it makes sense that our answer for 15 is larger than 14. It's supposed to be a larger package. Do you guys understand the conversions? Are there any questions about why I did what? The trick thing is when you see the answer, the problem seems really easy. You're like, well, duh, that works. Of course, it makes sense. The hard part is setting it up. Okay. So one large package, right? Okay, so, so mathematically, Chris. So in my calculator, I'm ignoring the ones because anything times 1 or divided by 1s is the same. And so what I'm doing is I'm taking, 1 times 0.75 times 16 divided by 1.69 times 57. Or, alternatively, you can multiply everything on the top. So 1 times 0.75 times 16 times 1 times 57, and you get 684 on the top, and then you multiply everything on the bottom. 1 times 1.69 times 1 is 1.69, and then you just do this division. 684 divided by 1.69, and that gives you 405. Does that help, Chris? Does that make sense? Good. No, not necessarily, Josh. So for the answer key on the way that it's graded on Canvas is I have kind of like a range. So as long as your answer is within like 5%, it's fine. I wouldn't round too far. Like on this one, I wouldn't round it off to 400. But it's also would be a little excessive to put, 404.7 and blah, 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 blah. Usually if you put 3 digits, you'll be okay. You won't get it wrong. You won't get it wrong if you put too many digits. You might get it wrong if you round it too far. I know, me too, Tiara. Me too. Okay, let's see. We've got 20 minutes left. We can do 16 real quick. Actually, 16's really easy. Maybe I'll just tack it off. I was going to do 18. When you program the questions as you round at the end of the computation, yeah, I just did. So Weaver, I used the numerical answer in the range function for the questions. So I just put a lower range and an upper range. You just write a number. So let me show you. Let me show you the actual quiz submission real fast. So like on, we just did, what did we do? We just did 15. We would just say 405. Done. 14 we would say 57. Done. Oh, so on that one, Zach, just to be safe, do 43.1. I mean, if you could maybe do 43.08. Oops. Something like that. Stop spamming the friggin' squid emotes. So yeah, Chris is right on top of it. Yeah, on 16, all we have to do is just multiply by 2. Because on 16, let me go back to it. 16 just asks how much will be earned. and I think I said the gross income, not the net income. So 16, right? 16, we want to know how much money he's going to make from the large package. And if we know the large package, right, we just found that the large package has 405 M&Ms. And if we know that one M&M sells for 2 cents, I think you want to do one last step where you say 100 cents is $1. Because I think I have it plugged in as dollars instead of cents. So you want to make sure you have to do it. No, you're good in you. You're good in you. We're gonna go through 18. Your answer is they're not gonna spend $567,000 on their kid. I'll show you 18. We'll walk through 18. It's a great problem. Okay. So on number 16, you multiply by 2 and divide by 100 because you want it in dollars. All right, we're at the point. Let's do 18. Olivia, unfortunately, we don't have time to do 17. If you want help on 17, I can help you in the Discord this afternoon. But I'm just going to do 18, and then we're going to be done. All right. The problem with 18 is a compound unit. So 18 doesn't have just one unit that you're canceling. It has 2 units that you're canceling. So I want to make sure you guys recognize this real fast on 18. So 18 says, so in 17, he runs away from home and goes in the mountains because his parents thinks he's dealing drugs. So in 18, though, in hopes the student would return home soon, the parents kept the porch light on. Right? They kept the porch light on, but they don't want to. They love their son, but they don't know if they love their son that much. They want to know how much it's going to cost. So the light bulb used 75 watts, and then 1,000 watts is a kilowatt, and a kilowatt hour is the amount of energy when a kilowatt of power is used for 1 hour. So this is where it's interesting because it's not a kilowatt per hour; it's a kilowatt for an hour. And so instead of having being kilowatts over hours, it's kilowatts times hours, which is weird. If a kilowatt hour costs 45 cents, how much does it cost to run the 75 watt light bulb for 1 full week, both day and night? Okay. So I have a hint here that says how you want to set up the problem, right? You want to set up the problem as how many dollars. I need $1. How many dollars is 75 watts? And then notice it's watts for 1 week. Okay. Now this is where it's interesting. Okay. We have watts and weeks, both watts and weeks. We have to cancel both watts and weeks. The issue is the only thing we know that'll get us closer to money is we know that a kilowatt hour is 45 cents. That's cool, Tyler. Okay. So what we want to do is we want to change our watts into kilowatts. So the problem told us that 1,000 watts is 1 kilowatt. Okay, so look at this. Be careful on this. Watts cancel with watts, but weeks do not cancel, and we have not canceled them yet. So we currently have gotten rid of watts, but we still have the units week and kilowatt. We're trying to find kilowatt hours. Right? So I need to change my weeks into hours. Now, because of the way multiplication works in math, it doesn't matter what order you multiply things in, right? As long as you're multiplying, you can do them in any order. And if I have an x up here, and then along in my conversion, I eventually have an x over here, no matter how many things are in between them, those x's still cancel. And so what I'm going to do over here, I'm going to say that 1 week has 7 days. right? Now this week and that week cancel. So now I have kilowatt days, right? So I've got kilowatts and I've got days. Reminder, we're trying to find kilowatt hours. So we do one more conversion where we say 1 day is 24 hours. This week does have 30 days. So a day canceled with days. So, okay, units that have canceled. We got rid of the watts, we got rid of the weeks, we got rid of the days. We still have this kilowatt, and we still have this hour. And so what we need is this is where we're going to use our problem they told us. They told us that 1 kilowatt hour, right? A compound thing, 1 kilowatt hour is 45 cents. Okay, 1 kilowatt times hours, right? You use a kilowatt of power for an hour, kilowatt hours, is 45 cents. Okay, so then this unit, this kilowatt up here, cancels with this kilowatt down here, and this hours here cancels with this hours there. So now everything is canceled except cents, which is good because we're trying to find dollars. And so the last step is 100 cents is $1. Okay, so the cool thing about this problem is that we're changing 2 units simultaneously. And we kind of do it independently until everything cancels. So in the end, I know that I've done this problem right because all of my units canceled properly and I'm left with dollars, which is what I'm trying to find. I think the answer is something like $5. 75 times 7,000 times 24 times 45. Yeah, so I get $5.67. And yeah, oh yeah, I feel dumb now. I didn't realize you needed to set it up for watts per 1 week. I thought you used week in the equation. Cooper's freaking out. Wait, what, Cooper? What's wrong? Did Cooper tune in too late to catch this? You got that answer earlier. Well, never even needed help. I'm sorry, Cooper. You missed an hour of your life. You'll never get that one back. Hello, Sophie. Is that's a... Oh, that's that... I do not parlez-vous Francis. I butcher French. Yeah, that's it, Tyler. We're done. What Pokemon is that? That's it's one of the newer ones. It's like Bareep or Mareep or I can't remember. It's the sheep one. I can't remember the name of that one. Wee Baguette, yeah. 16 I never actually answered. I don't know. It's whatever that is. 800 divided by 100. It's like $8. $8.02 or something like that. Hey, more Pokemons. Yeah, no, I love Pokemon. I grew up playing Pokemon. Like, Pokemon Red and Blue came out when I was in 4th grade, and so I played it like all the time at on recess and things like that. No, I've played most Pokemon generations. It's the only reason I bought my 3DS was to play Pokemon X and Y and then Sun and Moon. Mm-hmm. So yeah, Chris, if you wanted to do it, that way, you just multiply everything on top, multiply everything on bottom. So this would be 75 times 7 times 24 times 45. It's a really big number. It's 567,000 divided by, I think the bottom's just 1,000. Oh, 1,000 times 100. So whatever that is, that's 100,000. So 567,000 divided by 100,000 gives you 567. Thanks, Sophie. Appreciate it. Let's see. Ellie, quarantines maybe online shop so much. Yeah, a lot of people are coping using online shopping. Yeah, it's kind of crazy. My wife is doing that a little bit. We just got her birthday present. Her birthday is on Sunday. Cool. All right, so that's it for today. If you guys have any last questions, make sure to hop into the Discord. Oh, sorry, Trinity. Whoop. This is just me showing that if you multiply all the top together, you get this, and you multiply all the bottom together, you get that. So you take 567,000 divided by 100,000, you get $5.67. Will the first unit, like 75 watts, always multiply by the top? Yes, Chris. Yes. The first unit is always the top. Technically, this is divided by 1. We just don't write divided by 1. All right, so Weaver's class has Canvas updated with the submission quiz. Drake's calling people out for simping because we know Drake can't get the ladies. This is just some homework problem that I have from. This is like chemistry stuff. So this is kind of a preview to chemistry because I'm a high school chemistry teacher. So this is kind of some working through factor label. So you may have done this if you've ever taken a chemistry class. Oh, well then of course you know this. Yeah, so this is like Gen Chem stuff. So general analytical chemistry. But this is we're getting into like moles and grams that we're gonna talk about moles and gram conversions and stoichiometry starting on Friday. So this is kind of my way to introduce it with some cool like just fun story problems. Hey, that tier 1 sub. Let's go, Valen. Appreciate it. Okay, we're going to end. You guys are off task. Okay, so let's make sure you get this done and submit it to Canvas by tomorrow night. And then we'll be doing some more streams on Friday. I'll be in the Discord for help on any of these problems this afternoon. I think so, Chris. Well, you want kippers on top in the end. No, you want kippers on the bottom. You want jiggles on top. So I think you have to do 2 conversions. you gotta spam those emotes, Valen. And by Valen I mean Valen. Yeah, no, you're good, Chris. You're good. If you have more questions, you can ask. Yeah, Weaver will be in Discord too, answering some questions. So I'll be there this afternoon. Otherwise, have a great day. Enjoy your Wednesday. It's almost May. No, I got shorts on. I got shorts. I'm rocking the what's its name? Freaking John Krasinski, his some good news outfit. See, I got shorts on. Bye guys, have a great day.